Carolyn, I'll turn it over to you.
All right, thanks, Brian. Okay, good morning, everyone. As Brian said, I'm Carolyn Fries with Guided Particle Systems, and I also have with me here today Andres Serafim, who's one of our engineers. So Guided Particle Systems does development, design, manufacturing, and sales for equipment. We are a hardware company. We sell things that make things. We sell things that teach people how to do things. We actually do this in a variety of areas, but I'm going to focus on one for purposes of time today and kind of tell you about a new product that we just launched an MVP back in July. Okay, so caught up pretty quickly there. So if you've been watching the news today, you've seen a lot of current events around reshoring of semiconductor manufacturing or microelectronics manufacturing. These are some of the headlines here. And from back in July, the Skywater Technologies that's actually going to be building a fab in West Lafayette, Indiana, near the Purdue University campus. They also have a fab here in Florida in Orlando that's part of the bridge, which is part of Neo City in Osceola County. Just last week, actually, Osceola County was awarded $51 million by the Build Back Better regional plan. They were one of, I believe, 50 around the country that received this type of funding. So they'll be doing a lot of expansion on that fab to be able to produce things. So that's kind of what you're seeing in the news. The challenge is, what we're hearing is they're going to need anywhere between 70,000 and 90,000 skilled workers to be able to meet the need for the reshoring of semiconductor fab. That's a lot of people. It's a lot of people. It's a lot of engineers. It's a lot of technicians. And it's an industry that we typically have not done here in the States. So this is a pretty serious problem that we have coming up. Which also then creates an opportunity, because for every problem, there's an opportunity. These are US News and World Report, 1,400 community colleges and universities around the country. These are the folks that are going to be teaching those workers for tomorrow. There are actually closer to 4,000 colleges and universities around the country, but it's been pared down by US News and World Report. So this 1,400 is only colleges that have more than 200 students in them, that have four-year programs. So this is really the target that we're going after. And even within these, there's a certain subset of those that we're going after that actually have engineering and technology programs. So this is kind of the market that we're looking at here. And this is our solution to that. Back in July, we introduced Navi, which is kind of short for the Navigator. And our idea is that this program or this product will actually be able to help students navigate their way through the manufacture of semiconductor processes. Now, this isn't going to create any sort of a 7-nanometer chip or anything, but it's going to teach the basic concepts that they need to understand to be able to work in a fab. It's going to get them working with the materials. It's going to teach them some of the processes. And it's got some intelligence behind it, some machine learning, some augmented reality, mixed reality, to be able to teach students and interact with the students as well. Again, since we're focusing on targeting community colleges, we know it's hard for a community college to buy a piece of equipment for one class. So we're looking at this as being a very versatile platform that can be used for several different classes. So if you have a microfabrication class geared towards semiconductor fab, you have the end effector for the Navi that does the photolithography. If you want to just use it to teach a robotics class, you can use it for, take off the end effector, put something different on it, use it for that. If you want to teach about machine learning and machine vision, perhaps they're going to go work into an industry where they're using a robot to recognize and pick and place parts into bins or on crates or whatever, that sort of thing. You can use it for that. So there's a wide variety of things that you can do with it. This is a video, and I'll start it in a second, but I'll kind of walk you through what you're going to see, and hopefully it will work.
Feel free to continue talking. I forgot to do the share.
So we're going to demonstrate kind of the machine vision and learning, as well as some of the projected information. And then at the end, we're going to show you the photolithography step and then the development. And I'll kind of walk you through it. There's no sound on the video, but I'll walk you through as it's doing it. Hopefully it will do it anyway.
Jim's a magician. He can make anything.
You know, videos on Zoom, you just never know.
Forgot to do the screen share with you.
Okay, so hopefully. Okay, so you're going to see Andre here place this part on here. So this is essentially a circuit board that we have. We've gone through the training process already. So the camera on there is actually going to recognize that. It's going to know what it is. So right now it's kind of scanning along the surface. We could have put this in anywhere of 8 different locations on that platform there. So now it's kind of scanning across and it's first looking for something. Then once it sees it, it recognizes it. And I think we're getting to the point where it's recognizing it. Okay, so now it's like, okay, I know what it is, and I'm going to present some educational information about what I just saw. So it's like, okay, this is the NVIDIA board. Here's, it says machine learning. Here's some pinouts for the interfaces on it. Here's some specifications for it. You could really do anything on here. So now we're going into the patterning portion. This is just a circuit that we created or that we pulled off the web. It's actually kind of a low resolution. It's a little grainy, so we don't get the best image out of it. And actually at the end, I've got some things that you can pass around and take a look at. You're going to see some lenses that will split back and forth as you get close. You see these 2 lenses. This is a 10x reduction lens. And then the bright thing is actually a UV exposure. So it's exposing using UV light down onto that substrate there on the platform. That is a print plate. If you're familiar with like the old days when we did do digital printing, when you had print plates on big rollers that they used to roll the newspapers through. These are great to be able to do just quick turnaround. Plus, because they're hydrophilic, so they attract water or ink, you could potentially put a conductive ink on it and you could actually make a circuit with it. Wow. So this development process actually took about 2 minutes, but we kind of cut it for sake of argument here. So these can actually be used to make circuits and that sort of thing. Very quickly, we're actually working on the Pensacola State College campus out of a converted chemistry classroom. So we don't have to have a full out clean room with like class 100 clean and everything. You can do this in a converted classroom, which is also really important for the community colleges. So we launched this at the end of July at the High Impact Technology Conference out in Salt Lake City. Just some images from the booth there. As part of this, we kind of did some customer discovery. There were about 500 people at the conference. We walked away with about 30 leads of colleges around the country that were interested in the platform. These 2 guys are very big in the micro nanotechnology education space. So they are actually going out and helping to spread the word. Zach, the one at the top, has already talked about us to a number of community colleges that he works with out of Penn State. And then Jared is actually on the California coast. So we're pretty excited about the feedback that we've received on that. Kind of looking forward, this is where we're at today, where we announced it. So this is our MVP or minimum viable product. We're looking for early adopters. It's going to need some tweaking. It's not perfect yet for sure. For the rest of the year and into 2023, we're going to be making enhancements to it, some additional machine learning and intelligence behind it. We're also going to be working on curriculum, because that's one thing we're seeing with the community colleges. Getting faculty is very difficult to teach. So we need to be able to have a very simple program that's got a solid curriculum where they can almost, you know, with some basic knowledge, they can walk in and teach this class with the curriculum provided. Eventually, we'll improve the optics, have a better program to do research at the university level. And then ultimately, we're actually talking with the folks at the bridge about some packaging applications for more of a production platform kind of long-term. We're still working on what that needs to look like. Typically, they're done in silicon wafers, but they're looking at doing kind of large area panels. So we're still trying to figure out what they want to do there. And I think this is the last slide. Yeah, so hopefully I was close to that 6-minute range there. Yeah, so any questions?
Any questions in the room?
Who's your customer? Oh, I'm sorry.
Yeah, who in the community college is your target for connections? Who are you looking at?
Yeah, within the community colleges in particular, we're looking ones that have engineering and electronics programs. So typically, it kind of depends. Like in the case of Jared, he is an instructor, but he's extremely passionate. So it could be instructor level that really wants to drive it, and that's where we'll have the most success with the implementation of it. But we can also look kind of forward-looking deans that are willing to try something. We've talked to Valencia College down in Osceola County. They're kind of willing to do a lot of kind of crazy things. So, you know, it's really got to be kind of people that are willing to go above and beyond and do something a little bit different. In particular, I think I've got, we've also kind of created this map that shows where the semiconductor fab locations are around the country, and there will be more of them coming on. So obviously, you know, if you focus on community college that are say around, you know, Phoenix, Arizona, Dallas, Fort Worth, up in New York State has a lot, you know, Orlando, obviously with the bridge down there, California. So we're kind of targeting right now the areas that have local semiconductor fabs, because odds are they're the ones that are training the workforce for them.
Are you sourcing your robotics and software? Are you creating those robotics and software?
It's a mix. The robotic arm is actually an arm from Epson, which is a Japanese brand. Originally we were using KUKA, but then they sold out to the Chinese. So we're like, oh, maybe we want to change.
You mentioned like it's it doesn't get down to the nano, the super fine circuitry, but is there an opportunity here, for example, in the back panel of this TV screen, there are circuit boards that are probably at a gross enough level where this thing could create them. Is there an opportunity, and I don't know if that would be it, but there are certain circuit boards that are used an awful lot. Is there an opportunity for somebody to buy this equipment, open a manufacturing plant, and I'll use a flat panel and create flat panel circuit boards? In other words, I have to find out who's really, somebody's buying circuit boards for phones, somebody's buying, everything has a circuit board in it.
Right. Yes, so you can use it for circuit board fabrication. Current size on it kind of go down to about 25 microns. We have been as small as 1 micron in the past. What we're really targeting in the semiconductor area is packaging. So a lot of the inputs and outputs are the connections that are made between, say, the silicon chip and the interposer, which is kind of a, I don't know, maybe it's the jelly and the peanut butter sandwich, and the peanut butter is the chip. But these are kind of in the range of, you know, the smallest interconnect being 5 microns in size up to over 1,000 microns. So, you know, at this point, you're kind of in the millimeter scale. But this is kind of the size range we're looking at. So being able to do connections. There are other companies that are doing similar things to this that are really geared for high volume production. So we're really looking more for kind of low volume production, high versatility or high variety in designs, and also trusted source like for military and that sort of thing.
Are you only trying to get your foot in the door with universities and colleges, or could you be using this device in some sort of a certification program?
You know, we've looked at some certification programs. There's not a lot out there yet for semiconductor manufacturing. But yes, could be used, and it's just a matter of when the certs kind of catch up with the industry.
The technology could be used outside of the school education environment as a tool to try and get people up to speed to work in the industry?
Oh, definitely.
Okay.
Definitely. That's what we're targeting. Yep.
Carlos. Carlos, your question you had?
Oh, yes, sir. Is your company for profit?
Oh, still muted. Sorry. Carlos, we'll come back to your question in just a moment.
Over here, a question?
Oh, I was gonna say, is there any opportunity for you to partner with, say, like Samsung or some of the other companies that want this workforce to help kind of sponsor it and get you into because I mean, I know that a lot of universities partner with big corporations and then also, companies that help with the training to develop those programs, and maybe that would be an avenue to like both have like two funding. So it's the university helping to fund it, and also like a corporation that would need your technology or need that workforce.
Yes, definitely. So like a Samsung is going to kind of be similar to us in that they do a lot of things, but they're going to be providing the equipment in the fab as well as potentially the fab itself. So we're looking to work with Skywater potentially. We've had some initial conversations with them, as well as the Bridgeton in Orlando. We've also had some conversations with FLATE, which is the Florida ATE program, or Advanced Technology Education. It's sponsored by National Science Foundation. So we're working with FLATE and some of the other ATEs around the country to kind of get these into community colleges and make it part of like a standardized program for semiconductor education.
Yeah. Cool. Especially if it could be like a job works program, that would probably
Right.
be really appealing.
Patrick?
A comment and two questions. First, this is a really good deck, great presentation. And then two questions. Number
I'll go
one,
back
the
to,
video you showed with the large metal table with the holes in it. Is that the one that survived the hurricane on the second floor? It looks familiar.
no, it's not. It's actually, it's something that we had built.
All right, that's, and then the other question is, I know from talking with you over the years and that this is a very interesting sort of product service development idea. What else does guided particle systems have in their future pipeline? I'm just curious.
Oh, so this is just kind of a cool image. I don't know how closely you can see, which is why I kind of did the close up here. This one advantage is having the robot, the 6-degree of freedom robot, is you're not limited to like X, Y, and Z as far as your motion. You can kind of go over complex surfaces. So this is actually a part that we had done a few years back for, I will say, a prime defense contractor without naming a name. But we essentially created this hexagonal pattern across this complex surface, which that whole sheet was probably about this big. So we were able to actually create that hex pattern across that whole thing, including those, and they're all like interjoined with one another. So that's kind of one cool thing that we can do with it. But outside of Navi and the microfabrication platform, we've also got some kind of analytical equipment. We have an underwater mass spectrometer. We also have some underwater samplers that can be timed to take periodic measures of either biological or chemical things. So like, for instance, like locally here, we're having trouble down at Bruce Beach with some things in the water, I'll say. You could potentially put one of those samplers out there and you could set timings to take samples at certain times throughout, say, a 2-week period. And then when you bring it back in the lab, you would know which sample was taken when, and you could potentially time it with, oh, by the way, they flushed this system during that time, or, and potentially be able to pinpoint where the problem is. And actually in Miami-Dade, they're actually looking at using both the mass spec and the sampler for some of the issues they're having in Biscayne Bay right now.
Carlos, if you can let me ask your question, please.
Oh, yes, sir. Is your company for-profit, non-profit, or is it for-profit that has non-profit services?
We're a for-profit company. We're a corporation, S corporation for tax purposes, but I don't know, I guess we care about the country and we care about the environment. So our products kind of tend to go in that area.
You're a social enterprise.
Any more questions?
I have a question. Do you take any interns from college, like over the summer? Would you be open to any of that? I happen to have a daughter in the engineering program for material sciences at UF.
Oh, great. We do.
amazing.
Yes. We've got a great relationship so far with the University of West Florida Honors College, the Kubelman Honors Program there. We also have a relationship. We're actually located on the campus of Pensacola State College, and as part of our lease agreement there, we have to have at least one of their students on staff at all times as an intern. Our first intern that we had through them, he's now full-time for us. He's one of our techs. Yeah, so that's been a great program. Yeah, definitely interested in, opportunities for summer interns, engineering students primarily, physics, optics, electrical, mechanical. Actually, our mechanical engineer, he was another intern with us. And when he graduated, it was, I guess, a year ago, December, or almost a year ago, December, he decided to come on with us. And then, a few weeks before he was supposed to start, he's like, well, I kind of want to travel some. And so, yeah, since literally January, he's been traveling all around Europe. I think he's in South America right now. So he's working for us part-time, but he's been like everywhere in the world pretty much.
How many years have you been in business now?
We started in 2016.
Okay, great.
Okay. Just a quick question or comment, which I probably should have just waited, but do you know Joan Moretti? Did Stan Harper ever mention her?
I don't think so.
Let me use you to work on that connection.
Okay, and I had like some pass around, I got like some silicon wafers that have some, if you've never seen a silicon wafer, I've got some little bits and pieces back there if you want to look at them.
And the last question for you is, what can our community do for you?
I think probably the biggest thing would be connections. If you know anybody in the community college area or, you know, working in some of these kind of high tech areas, you know, tell them about us, connect us with them. I could also kind of use like a local sounding board because right now, you know, my husband and I are running the company. But it's kind of nice to get outside perspectives on things. So if anybody would be able to serve on kind of, I don't know, an advisory board, or I don't know, we could like buy drinks for you or something. I don't know. Figure out how that's going to work exactly. You know, sometimes just to be able to bounce ideas off.
I have a great idea.
Okay.
Thank you so
great.
much for.